Alright, in the last lecture we have talked about how to search for a given value in a single linked list, and hopefully you understand everything very well. Now in this lecture, we will learn how to delete a node from a given single linked list. In one of previous lectures, we have learned how to insert a node to the single linked list. If you remember, we had three cases there, which are insert a new node at the beginning of single linked list, insert a new node at the end of single linked list, and insert a new node at the given location. Similarly, while deleting a node from single linked list, we have same conditions over here. So we can delete a node from the beginning of single linked list, and we can delete a node from any given location in the single linked list, and we can delete a node at the end of single linked list. Let's see the first case, which is deleting first node in single linked list. Here, the first thing that we are going to do is to check whether the first node is the only node in the list or not. If it is the only node in the list, deleting it is very simple. So let's look at this case. So in this case, we have only one node in our single linked list. So we need to delete this node from here. This is very simple. We just need to update tail and head references over here to null. So by updating these references to null, it breaks the connection between head and to this node and tail to this node. So after the link between these first node and head and tail is broken, so the garbage collector in the memory will automatically delete the node over here. So with this, our deletion of a node from single linked list is finished. So let's look at the second case, where there are more than one nodes in single linked list, and we want to delete the first node over here. It's clear that in this case we just need to update the only head reference, because here we don't touch the last node over here, which means that the tail reference stays same. So in our case, for this single linked list, we had to change the reference of head from 001 to 111, which is the physical location of second node over here. By doing this, we are breaking the connection between head and this first node, and we are creating the connection between head and second node. So if we update the head reference to 111, it creates the connection between head and second node, and it breaks the connection between head to first node and first node to second node. Then when we delete the links to the first node and from the first node, the garbage collector again will come and destroy this over here. So our first node now is deleted. Now let's continue to the next case, in which we are deleting a node from any given location. So here we rely on loop, and by using loop we need to find a node which is before the node that we want to delete. Let's say we want to delete node 3. In our case, node 3 is with the value of 4, so we want to delete this node over here. And we have to traverse from first node to the second and stop over here. Then here we need to update the reference of second node to the fourth node, which is 5 over here. So by doing this, we are breaking the connection between second node and third node and fourth node. So let's see how this is working. The first thing we are doing here, we are traversing from first node to here. Then we are updating the reference of second node to the physical location of fourth node over here, which is 333. You see that the reference is changed. By doing this, the connection between second and third node is broken, and the connection between third node and fourth node is broken. And we know that when the links to the given node are broken, the garbage collector automatically deletes this node over here. So with this, deletion of a node in a given location is completed. Now let's continue to the next case, in which we are deleting the last node in single linked list. Here again we have two conditions. So the first condition is we have only one node in our single linked list. This will be the same that we deleted in the first case of first node. So here again we need to update the head and reference of tail to null, and this will delete the connection between head and first node and the head with the first node. So if we set these references to null, as you see, the connection is broken. So when we don't have any connection to the given node, the garbage collector will destroy this node from the memory. And the second case is deleting the last node from linked list where there are more than one nodes in single linked list. So let's imagine that this is our single linked list and we want to delete node 4 over here, which is with the value of 5. This is the last node in our case. The logic here is the same. we need to update the reference of node, which is before the last node, to the null, then reference the tail to this node over here. Because we know that the last node always takes null reference in a single linked list. But the question is, how do you find the node before the last node? So the answer is very simple. We have to run a loop until we reach this node over here. So when we find the node before the last node, we need to update the reference of this node to null. So it works like this. We are traversing from first node to the second, and from second node to the node that is, in our case, this is the node which comes before the last node. So when we reach this node, we need to update the reference of this node to null. And by updating this, the connection between this node over here with the last node is broken. Then the next thing that we are going to do, we need to update the tail reference to reference to this node. So as you see, when we update tail reference to 222, which is physical location of the node over here, it breaks the connection between tail and the last node. So when we don't have any link to this given node over here, the garbage collector destroys it from the memory. So with this, deleting last node from the given single linked list is complete. Now let's see how these three cases work in algorithm. We'll combine all these three cases in one algorithm. So let's see our algorithm. So our algorithm looks like this. Based on this algorithm, we will create method in Python. This makes our life very easier. So the algorithm starts from here. It takes as a parameter as a location, in which location that we are going to delete a node. So the first thing that we are going to do in our method is to check head. If the head exists or not. It means that if we have head, it means we have a single linked list. If we don't have head, it means that the single linked list does not exist. So we are terminating our algorithm over here. Otherwise, if we have head, which means that our head is not known, so we are continuing over here. The first condition over here is to check if you want to delete first node. So if you want to delete first node, you know that we have two cases over here. If single linked list is consists of only one node, or if single linked list is consists of more than one node. If it consists of only one node, then we are updating head and tail to null. And with this, and the connection between head and first node, and the connection between tail and first node is broken. So the garbage collector deletes the node and we are terminating our algorithm. In the second case, we have more than one nodes in the single linked list. We are just updating the head reference to the second node. And we know that first node's reference is the second node, so we set head is equal to first node's next. So by this, the connection between head and first node is broken and garbage collector deletes the first node from the memory. Then we are continuing to the next block over here, in which we are checking if we want to delete last node from the linked list. Here again we have two cases. The first case is if we have only one node in our single linked list. In this case it's same operation over here, so I'm not going to repeat it. But the second case is if we have more than one node in our single linked list. In this case, we need to loop through our single linked list until we reach the node that is before the last node. Then we set this node's next reference to null, and we need to set tail to reference to this node. So by this, we are breaking the connection between the node which is before the last node, and between tail and last node. Then the last node gets deleted. Then the third case is we need to delete a node from any given location. In this case, one more time, we are looping through the single linked list to find the node that we want to delete. Then when we find the location in single linked list, we are just setting the current node's next value to the next node's next value. We know that the next node's next value is the node after the next node. So by changing the reference, we are deleting the connection between current node and next node. So the next node in this case will be deleted. So this is all for this lecture. In this lecture, we have looked at three different cases of deletion of a node from the single linked list. Now in the next lecture, let's take this algorithm from here and implement it using Java.